Okay, so here we are on chapter 4. We're going to be talking about fiber, how it affects digestion, and our health as well. Let's see. So what we learned from our book is that the the sort of definition for fiber has changed a lot throughout the years, or decades, we should say. Um, we know that our fiber intake has drastically decreased over the last few decades. And we often think that it's just because, we started eating more processed foods, period. But what actually was kind of happening was that fiber was actually seen as something that wasn't really desirable. So they purposely took out those things. And then having grains last longer on the shelf because of the the germ being taken out of it. That was just kind of a side effect of it. But now we see fiber as more of a hot topic. It's being added to food more often. So we have some new definitions of fiber, and that's going to continue to evolve. So recently in 2018, the FDA did make a clear and concise statement about what is fiber. And basically that happened because, like I said, food scientists and engineers were adding quote unquote fibers to foods, to like protein bars or drinks and things like that to increase the fiber content, but there was no true ruling on whether or not that was fiber and whether or not those quote unquote fibers were eliciting the same physiological impact as true fiber does, which we'll learn more about. So basically what the FDA said was that to be called fiber, it's either non-digestible soluble fiber or insoluble carbohydrates. It could also be lignin. It's either intrinsic and intact in plants, or it can be isolated or synthetic non-digestible carbohydrates. So dietary fiber, we know, has physiological effects that are beneficial to human health. And there's lots of them, from heart health, our cardiovascular health, to our GI health. There's more and more studies, developing regarding these physiological benefits. So we'll talk a little bit more about that in a second. But first, how do we classify fiber? Old classification could have been more of a structural thing. Like, is it a polysaccharide or is it lignin? We'll see in a second that lignin is not a polysaccharide. All right, it's actually like alcohol polymers. But generally, what we see today, and probably what you've always heard in your classes, is that they're classified between soluble or insoluble fibers. This is also what we use primarily in educating patients or clients, just because it's a little bit more helpful in teaching them what these are. So this chart is a good representation of most of the fibers that we consume or hear about on the daily, and whether they're soluble or insoluble, some characteristics about them, what foods we typically get them in, and their fermentability. So what you see here, just notice this fermentability. So this means that our insoluble fibers, as you can see, have a relatively low degree of bacterial fermentation. All right. Whereas our soluble fibers have a relatively high. All right. Remember, we talked about our oligosaccharides, and you see right here, oligosaccharides were primarily in like beans and legumes, and those are what caused us to have more gas in our bowels, and that is because of the fermentability of it in the colon. So read through these. This will be important on the test to be able to kind of identify where each of these fiber types are coming from, like which foods, and then whether or not they're soluble or insoluble. Okay, so like I promised, I was going to show you the difference between our fibers and then our, sorry about that, our fibers and our lignin. Okay, so here we have our different fibers. We see cellulose at the top, pectin, chitin, beta-glucan. All right, and then we see chondroitin sulfate down here. And then if we look at this, we see lignin. So lignin is always kind of separated from our fibers because structurally it is not similar. Lignin is not a carbohydrate, but it is composed of polymers of these aromatic alcohols. So if you see, back to our fibers, these are composed of many repeating monosaccharides, so it's a polysaccharide. And they either have these alpha or beta linkages between their carbons, right? So they're polymers of monosaccharides, whereas our lignin is not composed of monosaccharides, right? They're not considered carbohydrates because they're made up of aromatic alcohols. So make sure you remember that. That's why lignin is always kind of considered outside of our fibers. Okay, so we have our beta-glucans. If you remember from your previous classes, these are, or I should say oats are rich in beta-glucans. And whenever you see like a claim on a can of oatmeal, it's usually going to say something about improving cholesterol levels, and that's due to the beta-glucan. So our chitin, this is a fiber found in the exoskeletons of insects and crustaceans. So think about, the insects or like soft shell crabs, stuff like that you would eat. You actually can get fiber from those exoskeletons. And then we have our fructans like inulin, oligofructose, and our fructooligosaccharides. We did mention our glycosaminoglycans earlier in the carbohydrate chapter. Again, these are going to include our hyaluronic acid and our chondroitin sulfate. Remember, these are the carbohydrates that we, as women, typically will see in cosmetics or in joint supplements because they attract and draw in a lot of water and moisture and help to kind of fluff things up or cushion them. But it is also included in this fiber chapter because it is a polysaccharide. All right. Then we have our oligosaccharides, polydextrose, and psyllium. Oligosaccharides, like I said, these are the ones that ferment a lot in our colon, and you'll find them in the legumes and beans. Psyllium, this is very often used in fiber supplements, and you may see this whenever you do your fiber supplement assignment. Okay, so be sure you look at resistant starches starting on page 102 in the textbook. Basically, what a resistant starch is they're naturally occurring starches that aren't able to be completely digested by amylase in the upper digestive tract. So they're quote-unquote enzyme-resistant starches. They're resistant to amylase, right? So these are often kind of like thought of as a fiber because they're not completely digested, and then they can move into the colon where they can be metabolized by bacteria in the colon. So since they're not fully broken down in the upper GI tract, they're not providing as much metabolic energy because we can't break it, we can't digest it and break it down enough to pull energy from it. So resistant starches actually could be providing less energy and decreasing the starch energy provided by foods, if that makes sense. So it can be that that starch is just like physically inaccessible, or it can be that the amylase or other enzymes just aren't able to completely break it down. Okay, so we have our 4 resistant starches here. Our resistant starch 1, this is one of those that's just physically inaccessible. Resistant starch 2, which we can find in our, let me double check with this one. Okay, yeah. Resistant starch 2, which can be found in like your really not completely ripe bananas or uncooked potatoes. So basically we haven't, these bananas haven't ripened enough, or we haven't cooked these potatoes to completely free up that starch. So it's going to be harder for our bodies to digest. It's going to be, we're going to need more amylase or, more enzymes to help break those things down, but they're resistant in the digestive tract. So we also can form some starches during cooking and cooling, which you see is cooking and cooling, and then think retrogradation. Okay, so whenever we cook legumes or we cook potatoes and then we cool them, starches will form, and these can be resistant. This would be our RS3, resistant starch 3. And then RS4, our resistant starch 4, are basically chemically modified to be resistant starches. These are just some ways that we can analyze the fiber content of foods, so don't worry about that. We're going to do a whole activity on the health benefits of fiber, but just know that there's, especially in the GI tract, the effects. These are the 5 main impacts that fiber has on the digestive tract. We're going to do an activity with that. And you can see that here. All right, so you have a question about diverticulosis versus diverticulitis. Basically, we have diverticulums if we aren't consuming high fiber diets or even adequate fiber diets. This is a diverticulum here. So this would be present with somebody that has diverticulosis. Basically, if someone has diverticulosis and has these diverticulum present, things like food can get caught up in here and become inflamed and then infected. That's what diverticulitis would be. So you can, feel partially normal with some diverticulum and have diverticulosis, but whenever you have things getting stuck in the diverticulum and it's inflamed and infected, that's when you would have diverticulitis. Okay, so that is the end of the PowerPoint. If you have any questions, I only have 15 minutes to go through this, so I'm trying to get through it as quickly as possible. If you have any questions, everything else that I didn't go through really intricately, you're going to be doing in your assignments. So let me know if you need any answers or need help on anything.